Good evening, everybody. Welcome to another edition of Up in the Air. I'm Dakota Smith alongside Haley Mitchell, and thanks for stopping by this evening.
Tonight we've got a great show for you. First off, we'll have our market analysis as normal with the natural gas futures markets. Then we'll have a dynamics lesson in meteorology, but don't be afraid. The climate science students are here to make it all make sense for you.
And I'll bring you the 8 to 14 day climate outlook for the continental United States, and then we'll wrap up with an investigation of the communication of the three sectors of the weather enterprise.
But first, here's Update in the Air.
A group of electrical engineers from Stanford have developed a material that could potentially change how we cool our buildings in a drastic way. The team of scientists created a material composed of quartz and silicon carbide that reflects sunlight and also efficiently radiates heat back into space. The material radiates heat at a specific wavelength in which it can escape from Earth's atmosphere and into space. This has impacts that may reduce the overall intensity of the greenhouse effect. This new device is capable of achieving a net cooling power of 100 watts per square meter. Projections show that if this cooling device covered just 10% of the common household, it would offset nearly 35% of the air conditioning cooling needs. The creators hope that their findings can be applied to buildings across the world, including areas that don't have access to air conditioning.
Beginning this summer, Maryland will impose a rain tax. Yes, it's exactly what it sounds like on its residents. The storm management fee, passed by the state legislature in 2012, will go into effect following a decree from Governor Martin O'Malley. In 2010, the EPA ordered Maryland to reduce stormwater runoff into the Chesapeake so that nitrogen and phosphorus levels, both pollutants at high levels to watersheds, would fall. This would cost the state an estimated $14.8 billion, a sum that will be collected as a tax on anything that prevents rainwater from seeping into the earth, like roofs, driveways, patios, and sidewalks, impervious surfaces that cause stormwater runoff. Maryland ordered its 10 largest counties to raise the money, and each of those counties is putting in a local rain tax in place by July 1st. Money will be spent to build and maintain streamland and wetland restoration projects, as well as public education and outreach. This new tax is predicted to cost homeowners between $50 and $200 extra per year, which has Maryland taxpayers feeling a little left out in the rain. On the other hand, some agree that action must be taken to curtail stormwater runoff and preserve wetlands. So while the rain might not, opinions on the rain tax certainly will stay up in the air. Next up, Weather Risk students will update us on the natural gas futures market.
As the 2012-2013 natural gas winter withdrawal season comes to a close, weather will start to have a lesser impact on the price of this commodity. However, the colder than normal winter we experienced may be starting to have an impact on the near-term future prices.
The last weekly storage report released by the U.S. Energy Information Administration on April 11, 2013 showed a 14 BCF withdrawal, which was right on par with market expectations. The prices rose and ended up closing at $4.18 that day to $4.26 the following one. This 8-cent rally in prices was a surprise to many people. This could be due to the fact that we had our coldest March since 1996, and the natural gas storage is well below the 5-year average.
However, the prices have decreased down to $4.16 today on Monday, April 15, 2013. This chart shows the comparison of injections and withdrawals from this year to last year. During March and April of 2012, there were injections of 54 BCF. This year, however, there were withdrawals of 410 BCF. This is due to the greater number of heating degree days that have occurred during this past year.
This is the temperature outlook for the month of April. As you can see, most of the country will be experiencing above normal temperatures with the exception of the northern plains. This could lead to greater cooling demand for the southeast and southwest, however, will not affect prices too much.
For Up in the Air, this has been Chad Ogerberger.
And I'm Ashley Zakowski.
Have you ever wondered why here in the Northeast, our weather generally moves from west to east? Well, tonight on All Things Atmospheric, we're going to discuss the Hadley cell and its overall role in Earth's atmospheric circulation.
The Hadley circulation, a thermally driven circulation. What do I mean by a thermally driven circulation? Well, at the equator, the Earth receives more radiation than it does at the poles. This creates an energy imbalance, giving rise to temperature and pressure gradients. The Earth, much like a living organism trying to maintain homeostasis or equilibrium, tries to eliminate these temperature and pressure gradients. One way it does this is via a circulation known as the Hadley cell. The image you see now is a depiction of what the Hadley cell would look like if the Earth had no rotation and therefore no Coriolis force. Where it is warm at the equator, the air rises to the tropopause and then is forced poleward primarily by pressure gradients. Without the presence of the Coriolis force, which acts to turn the poleward moving air circulation to the right in the northern hemisphere, the air would make it all the way to the poles, where it would eventually become cooler and denser than its environment and sink back down to the surface. As the air descends, it warms until it reaches the surface, where it is then forced equatorward by pressure gradients once again. With the existence of the Coriolis force, which arises due to the Earth's rotation, the Hadley circulation only really makes it to about 30 degrees north and south of the equator. Then, another non-thermally driven circulation known as the Ferrel cell, first theorized by Pennsylvanian William Ferrel, takes over. This whole process is repeated continuously because the Earth is always trying to balance its energy budget. Now, I will turn things over to Steve, who's going to talk to you a bit about the impact of the Hadley cell on our climate and weather.
Thanks, Brandon. So now that you know how the Hadley cell forms, you're probably wondering how this affects your daily life. Because the air rises at the equator and sinks near 30 degrees north and south latitude, the resulting bands of low and high pressure work to create some pretty distinct weather phenomena. At the equator, the moist, rising air condenses and produces thunderstorms in a process called convection. This forms a global band of high precipitation thunderstorms called the Intertropical Convergence Zone and can easily be seen on most satellite images. At 30 degrees north and south, the sinking of air creates a band of high pressure which acts to prohibit precipitation formation at these latitudes. This process is also why many of the world's deserts are found at these latitudes. As the air near the tropopause diverges away from the equator, the Earth's Coriolis force acts to steer the poleward moving air to the east, thus creating the subtropical jet stream. Conversely, at the surface, air moving back toward the equator is steered by the Coriolis force to the west, creating a feature known as the trade winds. This phenomena has been used by sailors for centuries to quickly reach the Americas and travel the Pacific Ocean. These winds also help to drive tropical storms across the world's oceans. Now that we know the Hadley cell's effects on our planet, Dan will explain how similar phenomena can be found elsewhere in our solar system.
Thanks, Steve. Do you remember what Earth's Hadley circulation would look like without the Coriolis force from Earth's rotation? As Brandon told you, we would get one giant Hadley cell in each hemisphere. That's actually what we see on both Venus and Saturn's moon, Titan. Like Earth, both Venus and Titan have solid surfaces and thick atmospheres, which means we can get Hadley circulation on each body. A day on Venus takes 243 Earth days, which is even longer than a Venusian year. Titan, on the other hand, is tidally locked to Saturn, just like Earth's moon, so its 16-day orbit is the same length as its day. Because of this slow rotation, Venus and Titan both have a single Hadley cell per hemisphere that extends from the equator to about 60 degrees north and south latitude. Beyond 60 degrees, where the Hadley cells descend, both Titan's and Venus's atmospheres become turbulent, giving rise to polar vortices as seen in this image of Titan. For Up in the Air, I'm Dan.
I'm Steve.
And I'm Brandon. We hope you've enjoyed our segment.
When severe weather strikes, you can go on your computer, turn on the TV, and nowadays even check your smartphone for weather information. But a lot of collaboration goes on behind the scenes in order to make a wealth of weather information available to you at home and to all of us meteorologists.
That's right, and that's where ISWG comes in. The Environmental Information Services Working Group, or ISWG, is an advisory group established by the National Atmospheric and Oceanic Administration, or NOAA. ISWG is comprised of 16 professionals involved in the weather and climate enterprise. Co-chairs of the advisory group include Ms. Nancy Colleton and Dr. Walter F. Dabbert. Ms. Colleton, president of the Institute for Global Environmental Strategies, is known for her numerous environmental communication and information initiatives that promote a better understanding of the changing planet. Dr. Dabbert, currently with Vaisala, is an environmental measurement company, is known for his outstanding contributions at the National Center for Atmospheric Research and within the American Meteorological Society. Other members include Dr. Phil Ardenai of Raytheon, Mr. Barry L. Myers of AccuWeather Incorporated, and the NOAA Science Advisory Board Liaison, Mr. Ray Ban of Ban and Associates.
So what does ISWIG do? Well, duties of ISWIG include providing advice on improving communication among the three sectors of the weather and climate enterprise: the public, private, and academic sectors. The public sector is responsible for observations, numerical weather prediction, otherwise known as weather models, and issuing weather watches and warnings. The private sector is responsible for customization and tailoring of weather and climate products and communication. The academic sector, on the other hand, includes universities such as Penn State and is responsible for maintaining education and research. Additionally, ISWIG is responsible for providing advice on incorporating scientific and technical capabilities to enhance NOAA products and services. Since the first meeting held in November 2009, there have been 7 formal meetings and 1 ad hoc meeting discussing several issues involving the weather and climate enterprise, such as communication between the 3 sectors. The working group has also contributed to numerous American Meteorological Society briefings and engagements.
That's right, and Laura Fergione, the acting NWS Deputy Director, recently stated that ISWIG has been highly instrumental in lowering a level of friction that previously existed among NOAA, the academic sector, and the private sector, encouraging open and collegial dialogue that better supports NOAA, the National Weather Service, and the weather and climate enterprise as a whole.
Wow, it certainly sounds like a lot of work goes into making the weather enterprise run like the well-oiled machine it does.
Yep, Tyler, that's true. And the weather enterprise wouldn't be where it is today without ISWIG.
Well, for Up in the Air, I'm Tyler Jankowski.
And I'm Dylan Durnick.
Now we're getting to that time of the year where every day's feeling a little bit better, even if it's a little bit cloudy or a little bit rainy. In the 8 to 14 day outlook, we'll take a look at what the weather's going to be like between April 24th and April 30th. Taking a look right into the temperature probability, throughout the entire Midwest, South, and Northeast, generally cooler than average conditions. Now that doesn't mean it's going to be terrible outside, just a little bit cooler than you may expect for this time of the year. Now out in the West, completely different story. Almost the entire western half of the United States above average conditions for this time of the year. As you can see, in California, 60% chance of above average temperatures. Now this points to an increased fire threat for this area, as California generally deals with fires every summer. The precipitation probability also points to an increased fire threat. Now we've seen this trend the past few weeks when I've done the climate outlook, and they're staying below average precipitation. So we're going to keep an eye on that in the upcoming months. Not much going on out here in the east, a blotch of below average precipitation in the south, and a little bit of above average precipitation throughout the north and northeast. Hopefully that eases the pollen count and your allergy symptoms. Thanks for joining me in the 8 to 14 day outlook. Hopefully your weather's nice between April 24th and April 30th.
Well, I'm certainly counting on that forecast to give us some increased rain for the spring, wash out the pollen counts, and maybe fix some of the allergy problems I'm having.
I feel you there. I hope the forecast verifies. Thanks for joining us, everybody. I'm Dakota Smith.
And I'm Haley Mitchell. Be sure to join us next time up in the air.